Hi guys, thanks so much for joining me today. And in this particular video, I'm going to talk about how to conduct an independent samples t-test in SPSS. Okay, so a couple of things as far as review before we get into the video is when would you conduct an independent samples t-test, right? What are the requirements? Well, the first requirement has to do with your particular variables, right? So anytime you conduct an independent samples t-test, you need one categorical variable, which is typically going to be also your independent variable, or the variable that you're manipulating. And you also need a continuous variable, which is typically your outcome variable or your dependent variable. So again, it could be something like looking at whether spatial memory is better in males than females, right? So our categorical, in this case, quasi-independent variable would be gender, and our continuous dependent variable would be spatial memory, right? So those are the requirements for when you might conduct an independent samples t-test. Okay, so let's go ahead and jump right into the specific example I have for today. So I'm going to go ahead and share my screen. Okay, and I've got a bunch of different windows open, so let me minimize some things. Okay, so for our particular example for this tutorial, we're going to be looking at a data set from an experiment where the researchers were trying to test the hypothesis that older participants as compared to younger participants would be able to remember more words than younger participants. So what they did is they randomly assigned, they didn't randomly assign, they took participants who were currently undergraduates or college students, and they also took participants who were in middle school, and they gave them a list of 30 words to learn. And then they asked each of their participants, both the middle schoolers and the college students, to write down as many words as they could remember from that list of 30 words, right? So a fairly simple experiment, right? So let's think about our variables first, right? So our categorical variable is going to be age, right here, of participant. So remember, with categorical variables, we use what's called dummy coding to enter them into SPSS, right? So they're associated with a particular numeric value, and that numeric value tells SPSS which levels we're comparing, right? So it looks like here, the way that they were dummy coded was a 1 stands in for middle schooler and a 2 stands in for undergraduate, right? So that's our categorical variable, or our independent variable. And then our continuous dependent variable is words, right? So the number of words recalled out of 30, right? And that's a continuous variable, and specifically a continuous variable on a ratio scale, right? Because ratio scales have an actual 0 point, right? So if one of the participants was really sleepy, or they were playing Tetris on their phone, I kind of aged myself there because nobody plays Tetris on their phone. Maybe they were playing Angry Birds on their phone, or Words with Friends on their phone instead of paying attention. So they remembered 0 out of 30. That's possible with ratio variables, right? Okay, so that's our experiment. So how do we set this up in SPSS? How do we tell SPSS to run an independent samples t-test? Well, we go to the Analyze menu, the same menu that we go to for most of our tests, and we go to Compare Means, okay? Whoops, lost it there, okay? And then we're gonna go to Independent Samples t-test, okay? And in this case, our test variable is going to be our continuous dependent variable. So that's number of words recalled, okay? So we're gonna pop that guy into the test variable box using that blue arrow there. And then our grouping variable is going to be our independent variable or our categorical variable. Right? So how do we get rid of those question marks there? What do those question marks mean? Well, remember I told you anytime we have a categorical variable, we have to use that dummy coding process where one of our levels is arbitrarily designated with a number and the other level is also designated arbitrarily with a number. So essentially what we have to do is we have to tell SPSS which number corresponds to which level. Okay, so we're gonna go ahead and do define groups, and all we have to do is give SPSS the numbers that we've used, right? So for group 1, middle schoolers, we have the number 1, and for group 2, undergraduates, we have the number 2. Okay, because that's how they were entered into SPSS. And if you need to check that, you would just go to variable view, which is the view we're currently on, and you would look at values, okay? And if you click on that, that'll tell you which number corresponds to which level. And again, these numbers are totally arbitrary, so you could put 3 for middle schoolers and 4 for undergraduates. You could put 0 for middle schoolers and 1 for undergraduates. The numbers themselves don't matter when we're talking about categorical variables. Okay, so I'm going to go ahead and click continue, and that will set our numbers for our grouping variable for SPSS. And then I'm just going to click OK. All right, so let's maximize this window so we can look at our tables, right? So first here we have descriptive statistics, right? So remember with continuous outcome variables or continuous dependent variables, our descriptive statistics are going to include N, which is our sample size for each group. Okay, so we have 20 participants in middle school and 29 participants in college. The mean of words recalled in middle schoolers was 16.30. Remember to go to 2 decimal points, right? So 16.30 as compared to the mean for college students, which was 19.48. Okay, and then we have our standard deviation per group, 3.29 and 3.19, and then our standard error for each group, so 0.774, 0.59, okay, for each of our groups, okay? And then here's the fun stuff, right? This is the results of our t-test, okay? So what have we got here? We've got our t-value, and we've got our degrees of freedom, and we've got our significance value, right? So your t-value would be negative 3.38, okay? And that negative is there because your group 1 mean is below the group 2 mean, okay? Your degrees of freedom is 47, and your significance value is 0.001, okay? So what does that mean? Well, our handy dandy decision rule is that if our p-value or our significance value is less than 0.05, okay, then there is a significant difference, okay? And this says two-tailed. If you wanted to get a significance level for a one-tailed test, which this is, you would simply divide this value by 2. But in this case, it really doesn't matter. We don't really have to do that because our result is already significant. Okay, so it's not going to matter. It just means we're going to have more zeros there, right? So then the only thing remaining is you want to write up your results in APA style. Okay, so I've got on your handout kind of an example of how to do that. So you're going to state your hypothesis. You're going to indicate the type of test that you conducted, and you're going to include the descriptive statistics for each groups, group 1 and group 2, and those include the sample size, the mean, and the standard deviation. You're going to remember to italicize all of your statistical annotations. So for example, M for your sample means is italicized, SD for your sample standard deviations are italicized, and your P value, or P, is going to be italicized as well. And one thing I did notice, and I apologize for not being consistent on this, is I would prefer that you don't report the actual p-value, and instead you just indicate whether it's greater than or less than 0.05, okay? Because that's how you would do it in a scientific journal, is you would just indicate that it's less than 0.05. If your p-value is very, very small, right? So if it's 0.000 or if it's 0.001, then you could indicate that your p-value is less than 0.01, okay? Just to indicate how confident you are that it's a significant difference. But if it's not smaller than 0.01, then you can stay with the convention of saying p is less than 0.05, right? So a lot of times in scientific journals, if you have a very, very, very small p-value, and you can indicate in your manuscript that not only is your p-value less than 0.05, it's less than 0.01, it's advantageous to do that because it indicates that you're very, very confident that it is a significant difference and not a difference due to chance. Okay? All right, so that concludes this tutorial, and I look forward to seeing you guys in lab, and feel free to reach out if you have any questions. All right, bye guys.